Good afternoon, everyone, and welcome to our latest Hips and SIPS webinar. So just to run you through the schedule for today, I'll proceed with the slideshow interspersed with some live demonstration. This will take about 30 minutes. Presenting today is Burns Foster, that's me. I'm the product manager for Hips and SIPS, and Dan Marash, who's one of our veterans from our Hips and SIPS support team. So, just before we talk about Hips and SIPS 8.1, for those of you that aren't existing clients, CARIS is a company that provides GIS software mostly to the hydrographic and marine community. CARIS has been in business for almost 35 years, and our software products are used all over the world. We have about 170 people in 4 offices, most of those here in New Brunswick, Canada. We focus primarily on marine GIS and have done quite well in that industry. For any that aren't familiar with Hips and SIPS, it is a comprehensive sensor data processing system. We support over 40 industry formats and easily handle large volumes of data. For more information, you can check out our website or contact us directly. Okay, so today we're here to talk about some of the new features in Hips and SIPS 8.1 and give you some live demos. We have a number of updates to the interface and functionality. I'll talk about those first. Then I'll go through the new SIPS engine for Hips and SIPS 8.1, and this also ties in nicely with the introduction of our Catalogue Editor, which we'll talk about at the end. Okay, there are a number of improvements in the interface, and some of them aren't so obvious, so I'll talk about those first. Many of you might remember the introduction of the color by sound velocity profile to the HIPS display, and this colors the lines based on the sound velocity cast that was applied to each section of a line. In 8.1, we've also introduced coloring by applied tide for tide zones, so you can see at a glance which areas are impacted by each station in a given tide zone. That started to clutter up the properties window a bit, so we also consolidated that to a dropped list here you can see in the upper right. Next up, for the last few releases, we've had a bit of a hybrid for project properties, where some things are in the properties window and other entries are only visible in a separate dialog. For Hips and SIPS 8.1, we've consolidated everything into that properties window, and from here you can set your coordinate system as well. On a related note, we've added a vertical datum property as an additional piece of metadata on the project. And like the Caesar file property, it isn't used in any functions yet, but we do have some plans there for the future. And the last item I want to talk about in the interface is the new display filter. So the old show rejected button, a mainstay for many years in HIPS, has been retired, and we've replaced it with a function that filters based on status, and not just for rejected. On the lower right, you can kind of see how it works. When active, the display filter only shows what is checked in the dropdown. And when inactive, everything in the editor is displayed. The neat thing about this is you can visualize, say, rejected, accepted, and designated independently of each other. For our HIPS veterans out there, I'll warn you the logic is a bit reversed from the old show rejected, and it takes a minute to adjust to. But once you get used to it, it's a much more powerful tool. So, enough talk about it. Let's show you what that looks like inside the interface. And I'm going to turn that over to Dan so we can run you through it.
So I'll open up a session that Burns has created first, Demo 1. So this is a bathymetry data set provided to us by NOAA for our training, and that's what we'll be using for this demo. So I'll start off by going to the Layers tab, and right at the top here, HIPS data. When I select that, I can go over to my Properties window. So now, rather than going to several different tabs to get this information, everything's within here. You can find all your general information, your coordinate system information. We have our new vertical reference that you can apply here. Again, this is just metadata and some other information about the project at hand. Also, if you click on your ship track lines, you can go over here to our drop down. And before, or in our previous versions, we added the SVP profile, or color by sound velocity profile, and now we have the color by tide. So when I enable that and middlemost click to refresh, you can now see in the lower corner here that one of the tide files has been applied for these few sections of the line, and another tide file for the rest of the data. So this was when we applied SEDDF to the data set. Our separate tide files are applied to these separate areas, or these parts of the ship track lines. The final thing I'll be showing, I'm just going to turn this back to status again. I'll go into my subset editor and make a selection here. And let's load that. There we go. So if I rotate this, the vertical exaggeration looks good. I'll go up to here and our display filter. So if I enable this display filter and click on the drop down, I can now define what type of flagging for the soundings I'd like to show. So right now we can see this is the specific flag types that are on. So if I turn off these 3 flag types, and let's make a few selections of our data, and I'm going to flag some as outstanding, some as examined, designated, and I'll reject some as well. And we can see all these now, all those specific soundings are now gone from our view window here. So if I go back up here, let's say I quickly want to just pinpoint where these specific flagging types are, I can actually turn off my accepted data and I can turn on each type of the flagging, so my rejected, designated, outstanding, examined, and now I can pinpoint these quickly and efficiently. With that being said, I can also have everything shown just by disabling or turning off the display filter, and now I can see everything now is displayed in the 3D in my subset view window. This is also can be used in your attitude, in your navigation, and in your swath editor. So these flaggings, even though some of the same flaggings aren't within there, you can view your rejected and accepted and turn them on and off using your display filter at the top here. So I'll pass this back over to Burns and we'll continue on.
Okay, thanks, Dan. So we've done some work on the functionality side as well. Although I won't be demoing too much of this, we've added support for 2 new post-process formats, P-Free Heave from Kongsberg and TerraPause, post-process navigation. And for the post-processed heave, we've actually renamed the Load True Heave dialog to Load Delayed Heave, making it a little more generic than it was previously to reflect we support more than one format. For the base editor users out there, you'll recognize this next one. We've added the shoal depth true position gridding algorithm as well. So this method is essentially a binning technique, and for each cell in the output surface, we keep the shoalest sounding from that area, and we remember the position of that sounding as well. This was an often requested feature for HIPS and SIPS, and it's finally here. And now lastly, we've beefed up our feature support with the addition of GML and formatted ASCII exports. This works on almost any feature type in HIPS, including ship lines, critical soundings, and Sidescan contacts. For GML, any attributes of these objects will be exported as well, so that makes it a great interchange format for many cartographic systems out there, including our own ping-to-chart tools. Okay, so the biggest change in HIPS and SIPS 8.1 is, of course, the new SIPS engine. So what's so exciting about this release is just how much faster and easier it is to process side-scan imagery. We looked at all of the user input over the years, feedback from our help desk, from user group meetings, feedback from training. We took all of that information, we pulled the SIPS engine apart, and we put it back together again with 2 main goals: speed and quality.
So what exactly was done to accomplish this?
Well, for SIPS 8.1, we looked at the entire workflow for processing Sidescan, looking for anything we could change or improve with speed and quality in mind. The first step for our users is, of course, conversion, bringing that data into HIPS and SIPS to start processing. In previous versions of SIPS, we could only store 8-bit intensity values. Many formats store much higher resolution data, so what would happen is we downsample this data on conversion to store it as 8-bit, which basically means we lose resolution in the imagery. Further to that, in some cases, if you use scaling to downsample, this would apply separately to each line, and it becomes really difficult to match any 2 lines in a mosaic after you've scaled their values.
What do you mean by 8-bit?
Good question. So I'm basically talking about how we store data as binary numbers, and how long they are dictates how many different values you can store. So for instance, an 8-bit number has a range of 1 to 256, which means I have 256 numbers I can use to represent an intensity value in a side-scan image. So now in SIPS 8.1, we can store up to 32-bit numbers, which is a range of about 4.3 billion values. And with that range, we don't have to downsample imagery anymore, and this means the native resolution of the sonar is kept from first conversion to final mosaic. For this release, we've updated the EdgeTech, Climb, and XDF converters to keep the native resolution, and we'll update the rest shortly. Now, once you have this data in SIPS, the next stop is the waterfall display, namely our Sidescan editor, to view the raw imagery, check your towfish altitude, and apply corrections. And just like our converter, the Sidescan display has been rewritten to keep the best resolution as well, and you'll see that in the first view of the data.
I can see that you're using the properties window instead of 7 tabs within the control window. It seems much more compact than before.
Right, so we've reworked the interface and all of the controls for the editor now appear in the properties window. This means less clutter and simplified controls. The waterfall window had an overhaul as well. As I mentioned, we're not downsampling the imagery anymore, and we've changed how we resample the image to display it. So you'll see a big jump in quality there. Now, talking about speed, the biggest change users are going to notice is all the corrections. So like beam pattern, TVG, etc., they're all applied on the fly in Sidescan Editor. That even includes the slant range correction. Now it always computes the best resolution, and for the user, you just switch between corrected and uncorrected image. And that way, with a few clicks of the mouse, you can figure out the best corrections, and you're done. So, I'm going to show you what that actually looks like inside the interface. So I'm going to jump back over to HIPS and SIPS. I'll just close out of the multi-beam data set, and I'll open our second SIPS demo data set. So in this case, we have the Sidescan data set. I prepared a few things ahead of time, but essentially at this point, this is right after conversion in terms of this this data and its processed point or its processed state. So really, I haven't done nothing except convert it into the application. And of course, we're going to bring it in, select a line, and now I want to take a look at my data now that I have it converted. So the first thing I'm going to do is open up the Sidescan window. And if I take a look in here, for those of you that have seen EdgeTech data before, you'll notice the quality is probably a lot higher than it was previously, as I mentioned about the scaling and imagery conversions. So now all of the controls are inside my properties window as opposed to that tab where it used to be. So the nice thing about this is I can collapse each one of these items down when they're not in use, so it really makes it nice and compact. So of course, first thing I'm going to look at is my display. Things like my playback speeds, my color map, if I want to invert that, depending on what you're more comfortable with, all these things. So all that, again, is applied on the fly. The other thing, of course, you want to look at first, in this case, the Sidescan towfish altitude came in from a sensor. Looks pretty good. I don't need to do any work there, but if I did, all my altitude settings are inside this dialog as well, so I can set my automated height detection tool configuration parameters. I can set all that in here, and off we go. So now when I want to see what that looks like, it used to be you'd run a slant range correction before you could see the final product. Now, as you may have noticed when I started it, all I have to do is click back and forth between raw and processed. So the process is really that simple now, and that's all I have to worry about inside the waterfall. So I've got a few corrections already turned off. I'm just going to flip back. So what you may have noticed that I just went through, here's all the corrections inside the Sidescan editor, and everything is done on the fly now. So here's my TVG correction. I can do, let's say, linked, and let's say I want to try out different values. All I have to do is type these into the interface. I can see what effect that has in the data immediately, and that's all I have to do. Just that easy. So we have TVG, we have gain shift, so if you need to shift, say, a port or starboard, or both together, we have our gain enabled here as well. I'm going to come back to beam pattern in one moment, but I'll skip over. There's a despeckle, so that's essentially our aliasing algorithm we can apply. And a new correction for SIPS 8.1 is this gain normalization. So what we have here is dealing along track. Occasionally there's variation in the power and gain, maybe some motion from the platform, or what have you, cause these kind of banding striped artifacts inside the Sidescan image. This gain normalization works along track using a moving average window to normalize, to sort of smooth out that ribbing effect or that choppy gain effect that you see going along track as the fish is moving through the water. So that's what that gain normalization does. And again, I can set that live in the display, see the effect it has in my data, all in real time. And of course, the last thing is beam pattern. In the past, what our users have done is made a selection inside the Sidescan window like this, and then created a beam pattern from a small subsection of a line. Something we've been told recently, time and again, actually, is the more data you can feed into a beam pattern, the better it's going to be. So something new for this version, if I just hop out of Sidescan Editor for a minute, you can actually select an entire survey and create a beam pattern from it. So in this case, I can create my beam pattern. I have one already generated here, but this would be the entirety of the process. That's all I have to do. And the nice thing about this is, if I come back the next day, I add a new survey line in. All I have to do is select an existing beam pattern file, and it's cumulative. So we'll simply add the new information to the beam pattern. I don't need to regenerate the whole thing from scratch. So as I mentioned, I've actually got it already created for this particular data set. And in this case, it's already pointed to inside my waterfall display. All I have to do is turn it on. So I can do port and starboard separately if I like, and that's it. So literally in a matter of 5 minutes or so, I've set up my corrections on my image. I can take a quick run through the other survey lines if I'm interested, or now I can just jump straight into products. So in this case, the mosaic. And I have a little bit to talk about there as well. So the next step, as I mentioned, is creating a mosaic from the Sidescan image. In the past, our existing users will remember geobars, which are the individual line mosaics you create before stitching them together to make that final mosaic. It was a nice idea, but in practice, it was way more than most people needed. So in SIPS 8.1, you no longer need to make geobars. You just select the lines you want and go.
So what if I already created geobars? Can I still use these?
Yep, the original workflow is still supported. In fact, you still take that route if you need to customize different corrections per line. Or for instance, if you have a multi-sonar survey or surveys taken at different time periods under different conditions. We found that in most cases, our users have one sonar and a single survey they want to make a mosaic out of. And our new workflow is really tailored to that. When you create a mosaic without geobars, you use one set of corrections for the entire survey. Okay, so in terms of the mosaic, I've actually already created one here from my imagery, so I can turn that on. In terms of the process, all I have to do is select my lines, head to the process menu, and go to new mosaic. So again, I don't need geobars created. I can dive straight into this. And if I look under this advanced tab for the mosaic, I can see all the same settings from the Sidescan editor or waterfall display. So there's my beam pattern, port and starboard, my gain normalization. So the two are linked. So whatever settings I configured in the waterfall when I go to create the mosaic, those are the settings it's going to use. So that again makes things nice and simple, really quick workflow for getting products out from Sidescan image nice and quick. And that's the final result. So that's a 20 centimeter mosaic from this training data set. And again, minimal configuration, took me 5 minutes to set up those corrections, and away we go. Okay. So of course, the last step in the survey is generating Sidescan contacts, or features you can use to position objects, update charts, etc. In HIPS and SIPS 8.1, we've added the attributes window to HIPS. So this gives you the attributes for each contact feature you create. Those attributes are now extendable from our new Catalogue Editor, meaning you can add your own information to each contact. You can add your own Sidescan objects too. And this extends to other HIPS objects as well, so namely track lines and critical soundings. You can extend those objects with your own attributes as well. Now, a little preview of what's coming in Update 1 for SIPS 8.1. You'll see we've added an image preview window. When you digitize a new contact in this version, we generate 3 images and store them in the HIPS file directly. Then these images can later be exported to TIFF, and when other CARIS applications start opening the HIPS file, they'll have direct access as well. So I'm going to show you what that looks like, and for that, I'm going to turn it back over to Dan.
Alright, so I'm going to first go back into Sidescan Editor. I'm going to select this ship track line here, and I'll open Sidescan Editor. So now that I'm in Sidescan Editor, I'll show one of the new windows, going up to Windows and down to Attributes. So we have our Attribute window, which was added over here by our Properties window. And I'm going to start off by creating a contact. So I'll create a point contact. Now, if I go down here and expand my contact window, we can see the point contact that's going to be created is actually an underwater rock. And if I were to choose line, it would be cable. So this can be changed here, going by what you have for your options. So I'll go and I'm going to create an underwater rock. And then I'm going to go back up to my toolbar and select this particular contact. And we can see down here in the attribute window, we have some default attributes that are associated with underwater rock. So with that being said, I'm going to close out of here. I'll save that rock contact to the contact file. And I'm going to go over to my project tab and make sure my SIPS training project is selected. So with that selected, I can now go up to my file in Catalogue Editor. And what that's going to do when it opens up my Catalogue Editor is we can see SIPS training is the title up at the top here. And this is actually the attributes and objects that are within every HIPS file defaults. And now any new attributes or objects that I create will be automatically saved to this SIPS training project into my HIPS file. So let's start off by adding some actual new customized attributes. So I'll expand my attributes. You can see all of our default attributes that come with every HIPS file. I'll select attributes, right click and go to add, and we have several types to choose from. And we'll start off with the enumeration. So I'll go enum and go OK. And we'll give this a name at the top. We're going to call this type. And for our name, let's give it a name of feature type. And description type of feature. So now that we've filled in this information, we have a new acronym type. Let's give it some options to choose from. So I'll expand this down, and for my first name, I'm going to say rock, enter. We'll add a second option, brick, and let's add one more and call this one kelp. So now for our new attributes, our type attribute, we have three options to choose from. And that type attribute, as you can see, has been added here. So let's generate one more. I can go up to my toolbars, add, and let's do a date and go OK. So under date, I'm going to call this one reported on. And again, I'll give it a name and a description. Reported on. So reported on and date the feature was reported on. So with that, I can go save. These two customized attributes have now been saved to my HIPS file. And I'll just collapse my attributes and expand my objects. So we can see there's several objects here that come by default. There's also the option of going up to the toolbars or right-clicking on our objects and adding a new object. So we're going to be working with the underwater rock, but we can also add customized attributes to critical soundings or our lines. So I'm going to expand my underwater rock, and again, these are the attributes that come with that. But I can right-click on that and go to add. And with add, I can now add my type and my reported on customized attributes to that particular object. And with that, I can also set some of these as mandatory. So if I wanted to make sure that type was always filled in, I could set that to true, and again now save, and I can exit out of my Catalogue Editor if I'm all done, and all this information is now saved within my .hips file for this SIPS training project. So I'll exit out, and I'm just going to quickly close this project down and reopen it. And I'm going to select this bottom line. This is where I created that rock contact. And I'll go back into my Sidescan editor. And as we can see, if I go up here to my selection and select it, we now have the type highlighted by red. So it's a mandatory, which I can define as rock. And I can also put in a Julian day and go OK. So now if I wanted to add one more contact, let's just add one here quickly. We can see that information could be filled in for here, and I could go back to the previous created, and that information has been saved once I save, or if I were to exit, it would prompt me to save that. So with that being said, I'll pass this back over to Burns, and we'll continue on with the slides.
Okay, thanks, Dan. So that's the end of the demonstrations for our subscription members. You can download HIPS and SIPS 8.1 directly from our website. For non-members, contact your account manager or send us an email.
Keeping connected with CARIS is really easy. Today's webinar is being recorded, and it will be available for viewing on the CARIS YouTube channel. You can see the URL on the screen, and we are also on mediums like Facebook, LinkedIn, and Twitter. CARIS is going to be attending some events in the coming months. You can always check our website for the details on what conferences we will be at and if there are any open training sessions in your area.
We'd also like to take this opportunity to invite everyone to our users conference in 2014 in Brest, France, and the theme this year is Developing the Blue Economy. For everyone watching today, I wanted to highlight that we'll be hosting a HIPS and SIPS bootcamp and a HIPS and SIPS user group meeting at the conference, which is a great opportunity to come out and learn about the latest tools in the software and meet with other HIPS users. The user group meeting does help define the direction of HIPS for the next few years, so I really hope to see a big turnout. The conference website is now live. You can check that out at the address on your screen for more details. And that's the end of our webinar. Thanks for watching, everyone.